Very good. Thank you. Thanks for coming out tonight. We are going to have a skeptics forum tonight, and I hope you brought some great questions, because Hugh Ross has some great answers. So tonight we are going to, you can ask any question that you want regarding science, faith, the Bible, anything. So Hugh is going to open with a talk, maybe 20 or 30 minutes, and then we're going to open it up to questions. There's a microphone back there on that little table back there. Grab it, turn it on, and ask a question, or you can text your question in to my phone, and that phone number is coming up, 626-390-0236. That's the number that we're going to text to. We're streaming this, so we'll be getting questions probably from all over the country and all over the world, which makes it pretty exciting. There's a book table over there with Colleen and Diana. Say hi to Colleen and Diana. They have a lot of the material from Reasons to Believe, and Hugh Ross's books especially. Say thank you to the audio-video crew over there who came like really early and set up all the live stream. Thank you, you guys. Terrific. And one of the things that makes this fun is the treats. So we want to say thank you to Nancy Weigel and Helen Masada for bringing the goodies back there. Yeah. We're going to go till 9 o'clock tonight. And at 8 o'clock, we will take a break, and we will do a drawing. You notice on your chairs there is a card. If you fill the card out and get the card to me before the break, we'll put them in a box and draw names, and we'll give away these 3 products here, 2 books and a video. No, Phil, you can't do 2. I heard that. I heard that. He said, let's do 2. I remember one guy one year, he filled it out, and he took the card, and he bent the card like this, like so that we would pull that out more easily than. And I said, no, you can't do that. That Christians don't cheat like that. Okay. One announcement. This Thursday, so in 3 days, February 28th, at Reasons to Believe in, is it Covina? Covina. At 6:30 in the evening, we are going to be doing another Q&A. It's called Reasons Forum. And the speaker that night will be A.J. Roberts. She is a virologist. And that's going to be very cool. If you can't make it, it also will be live streamed. If you go to reasons.org, you can listen to that talk. But she's pretty amazing. It's worth driving out there Thursday night to check her out. Not as amazing as Hugh Ross, though. Not quite.
Well, she's got a lot of amazing things to say about viruses.
She does. I want to introduce our speaker tonight. Dr. Hugh Ross has a BA in physics from the University of British Columbia and a PhD in astrophysics from the University of Toronto. He's founder and president of Reasons to Believe, which is an organization dedicated to the integration of science and the Bible. The author of 17 or 18 books, lost track, many of which are over there on that table. If you text in a question, it would be cool if you would identify yourself, like just a first name and whether you're here in the audience or whether you're out there watching the live stream, just so we know who it is. It's more fun to announce it if you're from like Mexico City or something. I think that's it. Again, you can ask any questions you want. They don't have to be related to the talk that Hugh is going to do. So,
I just turned mine on.
oh, okay. So please welcome Dr. Hugh Ross.
Well, thank you. We want to devote most of the time to your questions and your issues. So I've trimmed my talk down to a little bit less than 15 minutes. But I thought you'd just be interested in some of the latest scientific discoveries. Some of you, I noticed, were with us yesterday. So it's going to be very similar to what you heard yesterday. But I know a lot of you here weren't here yesterday. So, and you know, this is just a short talk on some of the latest scientific discoveries that support the Christian interpretation of the universe and Earth. But it's also kind of fun in that these are discoveries that basically explain why we have civilization. And the bottom line is what they discovered are 3 amazing asteroid colliders that have made possible modern civilization. So it's like God is throwing rocks at planet Earth, but throwing rocks at just the right time, at just the right place, of just the right components in order to make possible our modern high technology civilization. As you heard, I'm the founder of Reasons to Believe, and you can engage us through a variety of social media venues. We actually have a dedicated Reasons to Believe YouTube channel where you can see material 24/7. And we do answer questions on Facebook and Twitter. You can contact me through texting Hugh to 31996. That's your portal to get free videos, book chapters, articles, and much more. And if you simply Google my name and attach Facebook or Twitter to it, you'll get to my pages there where I post a lot of the latest science that's giving us more evidence for the Christian faith. It's also a place where I engage people with their questions. So if you don't get to ask your question tonight, or if you're like me, I always think of my best question the next day, then you can take advantage of contacting me through Facebook and Twitter. And a couple of the chapters we're giving away is a free chapter of one of my latest books, The Creator and the Cosmos. You can get that by going to reasons.org/Ross. We're also giving away a free chapter of my book, Improbable Planet, same site, reasons.org/Ross. Matter of fact, last time I looked, they're giving away chapters from 5 different books. So you can take advantage of that. Now, how many of you ever heard of the Eltanin Collider? Okay, if you were here with me yesterday, you heard of it. The Eltanin Collider is a big asteroid that fell in the Pacific Ocean. This is the location of the collision site, and they've only discovered it recently because it fell into that part of the ocean that is 17,000 feet deep. And so it was just a research ship that by chance was making sediment cores off this area, and when they pulled up the sediment cores, they found it was filled with meteorite fragments. And so they sent the ship back in 1995, 2000, and 2005, and what they discovered is there's meteorite fragments scattered over a 30,000 square mile area. And they were able to determine that the asteroid that hit that part of the ocean had to be at least 1 kilometer in diameter and was probably 2 kilometers in diameter. And so when it hit the ocean, it caused a big splash. Matter of fact, they calculated that it would send tidal waves running through the Pacific and the Atlantic 1,000 feet high. And so what they did is they looked on the shores of 4 different continents, and they're able to find the splash debris from this collision. And they're able to drill down to the site. There's no crater there because the 17,000 feet of water basically prevented a crater from forming. But the little red dot there that you see on the map, that would be the size of the crater if it hit on a continental landmass. So it's a major event, and they've just recently been able to date when it hit, 2.58 million years ago. And that was surprising because that's what's called the Pliocene-Pleistocene transition, where we go from the Pliocene epoch to the Pleistocene epoch. They say, what on earth is the difference? If you're not a geologist, you may not know what that refers to. The Pliocene is the era from 5.3 million years ago to 2.58. It's a time when the planet was quite a bit warmer than it is today, but it was gradually getting cooler and it was getting a lot drier. And that was a time when ice was just beginning to form over Antarctica. Then we have this asteroid colliding into the ocean. It not only sent up these vast tidal waves, it sent up a huge cloud of water vapor, sea salt, and because it went all the way down to the bottom there, it also sent up a lot of ocean floor debris, particularly a lot of sulfur compounds. The end result was it formed a dense cloud that was so thick it blocked out the light of the sun. And so it had a dramatic cooling effect on the surface of the Earth, and the tops of the clouds were efficient reflectors of sunlight. So there was 2 cooling effects. The sunlight was reflected off the top of the clouds, and the thickness of the clouds prevented sunlight from getting through. Think of a really cold winter that lasts 3 or 4 years. That's kind of what you're facing with this event. And what it did is it dramatically sped up the freezing over of Greenland. That's when the Arctic ice cap formed, and the freezing over of Antarctica. And because ice and snow reflect sunlight with 60% efficiency, as opposed to open ocean water, which is only 6%, it dramatically cooled the whole planet. And 2.58 million years ago is when, for the first time in the history of the Earth, we went into not just an ice age, but an ice age cycle. An ice age cycle is where we oscillate between 10% of the planet covered with ice, like it is now, to 20 to 23% of the planet covered with ice, like it was 25,000 years ago. 25,000 years ago, just a little bit north of here, the ice age came all the way down. 55% of North America was covered by thick sheets of ice just 20,000 years ago. And so what happened was that we have this delicate balance between no ice, and that actually generated a cycle that was determined by the variation in the tilt of our rotation axis. As many of you know, the rotation axis is tilted at 23.5 degrees. What you may not be aware of, it actually varies a little bit. It goes all the way to 22 degrees and as far down as 24.5 degrees. And that cycle is 41,000 years. So when this asteroid hit, it ignited that cycle. And so we would have these cycles of glacial periods when 20% of the planet was covered with ice, and then there'd be a short period, like about 3,000 or 4,000 years long, when it was just 10% covered with ice. And this 41,000 year cycle persisted until 800,000 years ago. Now, what happened 800,000 years ago is we got another asteroid colliding with the Earth. And this is the collision site. That little red spot you see there is the minimum size of the crater. The blue represents the maximum size of the crater. And it hit in a place that's called the Spratly Islands. If you've been following the news, you know that there's 6 different nations all claiming sovereignty over these really tiny islands. However, before this asteroid hit, they were not tiny islands. It was actually a set of really big islands, but the asteroid collision basically obliterated these islands and just left tiny specks behind. And it hit at an angle that caused a massive dust cloud to leave the Earth and go in orbit around the solar system. And it's such that our planet crosses that debris cloud once every 100,000 years. And so what happened 800,000 years ago is the Ice Age cycle switched from a 41,000 year period to a 100,000 year period. Now, we wouldn't be here today if that hadn't happened. Because if all you got is an interglacial that lasts 3,000 or 4,000 years, that's not enough time to launch global civilization, and especially global high technology civilization. But now we have a 100,000 year periodicity. The average time that the ice interglacials last is about 10,000 years. And 10,000 years is enough time for humans to launch and establish global high technology civilization. And this is what the 4 last ice ages look like. This is from ice cores that were drilled in the thick ice of Greenland and Antarctica, and basically shows you the temperature, the global mean temperature over the last 400,000 years. And what you notice there is that you have the planet goes through a very dramatic warming. Notice how rapidly the temperature jumps up. Jumps up about 12 degrees centigrade, hits a peak, and that peak is about 3 degrees centigrade above where we are right now. But when it hits that peak, it starts another ice age cycle. And for the first time, we actually got a good idea why that happens. The reason it happens is when the global mean temperature goes up that much, it melts the polar ice cap. And instead of that polar ice reflecting sunlight with 60% efficiency, you got open ocean Arctic water that reflects it with only 6% efficiency. What happens to all that extra heat that the Arctic Ocean absorbs? It becomes snow that falls over Siberia and Canada. And yes, when you warm the temperature up that much, Canada and Siberia get a lot warmer. Instead of it being 50 below, it's only 40 below. But you know, when it's 40 below, you're still going to get snow. It's not going to rain. And so the enigma is global warming brings on global cooling. Because what happens is you dramatically increase the precipitation over Canada and Siberia, and you get thousands of feet of ice covering all of Canada and Siberia, large parts of Europe. 1/3 of the United States gets covered with ice, and ice, of course, reflects sunlight very efficiently, and it winds up dramatically cooling the whole planet. The other thing you notice from this temperature curve is that during the Ice Age cycle, the temperature is varying very dramatically. In fact, this doesn't do it justice. The temperature actually jumps up and down by about 10 degrees centigrade every few centuries, and explains why humans that were living here on Earth 30, 40,000 years ago were actually as industrious as we were. There's evidence, for example, that they were growing grains, harvesting the grains, roasting the grains, and grinding them to make bakery products. But it was all done on a very small scale. Such a small scale that this has only been discovered in the last 18 months. Because people were looking for large-scale evidence of agricultural activity. But when you got the temperature jumping up and down that much, it's impossible to launch large-scale agricultural activity or large-scale baking industry. And typically what was happening is a farmer at that time would plant 12 different crops, 8 would fail. He couldn't predict which 4 were going to make it, but he would feed his family on the 4 that did make it. Same thing with the animal husbandry. They couldn't count on specializing on cows or goats. They would have mixed animal husbandry, and they would survive on the ones that would make it through the temperature changes. Now, what you notice is, looking at the previous ice ages, you get that time when a very short period of time the temperature jumps from about 13 degrees centigrade colder than it is now. That's about 22 degrees Fahrenheit colder, and it goes up very rapidly. That didn't happen with the one we're in right now. The reason it didn't happen, there was another asteroid that collided with the Earth at just the right time in just the right place. And this was only discovered a few weeks ago. And it got published in the British journal Nature. And this is a collision that took place just 12,800 years ago. And you say, how can you hide a collision event that big, that recently from discovery? Well, it turns out the crater is 3,000 feet underneath ice. And only recently have they actually been able to explore. They basically sent an aircraft over northern Greenland, and the radar was able to penetrate and give an image of what was below that 3,000 feet of ice, and they found a crater. Then they sent scientists to the site, and were actually looking at the water flowing out from underneath the ice, and they noted that the water was loaded with the elements that are highly abundant in asteroids as opposed to Earth material. This map shows you the collision site. Basically, it collided in northwestern Greenland. That little red dot there actually shows you the size of the crater. It's about 20 miles in diameter. And also, this is an asteroid that's bigger than a kilometer in diameter that collided just 12,800 years ago. And it had a dramatic cooling effect on the planet. This is a time when the temperature was going up, because you know, when our rotation axis tilt goes from 22 degrees up to 24.5 degrees, it dramatically warms the planet. The greater the tilt, the warmer the planet. So this is a time when it was warming, and warming very rapidly, but right in the middle of that warming phase, this asteroid hits, and it cools down the whole planet, because it basically sent up huge amounts of ice that came on the Earth, and what it did is it blocked the flow of a huge glacial lake in the middle of North America from going down to the Gulf of Mexico and instead going out the St. Lawrence and the Mackenzie River. And what that did is it flooded the North Atlantic Ocean with cold, glacial, fresh water. And what did that do? It turned back the Gulf Stream. So instead of the Gulf Stream warming the North Atlantic continental land masses, suddenly they now became very cold. And this is what the temperature profile looks like. So that little purple line there, you can see the dotted lines. Those two dotted lines show you what's called the Younger Dryas cooling event. And we now know the asteroid is responsible for that cooling event. But what that cooling event did, it prevented the global mean temperature from going up to its normal maximum. It stopped about 3 degrees centigrade short. And for a brief period of time, it stabilized the temperature of the Earth. Now, that little blue line there shows you the global mean temperature for the past 9,500 years. Notice how stable it is. It basically shows you the global mean temperature over the past 9,500 years has only varied by plus or minus 0.65 degrees centigrade. And that's what's made possible our global high technology civilization. Now that we can count on the fact that the temperature is not going to change in any dramatic way, for the first time humans could specialize in their agricultural industry. 10,000 years ago is when humans for the first time began to plant enormous regions of land, like a whole square mile, and plant nothing but wheat. And they get a huge harvest of wheat, and they would trade that wheat for goat products or pottery products or metallurgy products. And so this is when trade began to take place. This is when you see the first cities and villages being built. And it was all possible because of this stable temperature. Now, 9,500 years ago is when the tilt hit a maximum, and then we now have the rotation axis going from 24.5 degrees down to 22, which means we're in a cooling phase. And what you notice in looking at that blue curve, the temperature of the past 9,500 years has very gradually declined by 1 degree centigrade, only 1 degree. Now, because of our aggressive technology in the last 70 years, that whole 1 degree has been completely recovered. So for 9,500 years, the global mean temperature cooled by 1 degree. In the last 70 years, it's gone up by 1 degree. And that's just because of human, industrial, and scientific and technological activity that has happened. But the amazing thing is, when scientists look at this, we've got the tilted rotation axis, which should be dramatically cooling the planet, but it didn't happen. Instead, we got a very slow cooling. The reason why is that brief epoch of climate stability enabled humans to launch the domestication of cows. And so the cow population went up, and they began to breed the cows to be more efficient in producing milk and meat, but that had the side effect that they emitted a lot more methane than the wild cows emit. And you got more of them, and methane is a powerful greenhouse gas. And so here's the tilted rotation axis cooling the planet. The domestication of cows warms the planet. And then a little bit later, people in Asia began to domesticate rice, and they quickly figured out they can get a much better harvest if they flood the rice fields. By flooding the rice fields, they basically eliminate the vermin and the different diseases that would attack the rice, so they've got a much better harvest. However, when you flood the rice fields, after you harvest the rice stalks rot and you get methane. Again, a powerful greenhouse gas. And then humans began to cut down forests and transform them into farms and meadows, and that also had an effect of warming up the planet, because now less carbon dioxide was being absorbed by the trees that were there. But here's the amazing thing. You've got the tilted Earth's rotation, and secondarily, you also have a variation in the Earth's orbit about the sun. When it's more eccentric, you get a warming effect. When it's less eccentric, you get a cooling effect. Well, both the change in the eccentricity of Earth's orbit and the change in the tilt of our rotation axis is causing the planet to get colder. Both of them are making the planet colder, but human activity is making it warmer. But don't you think it's amazing? The two have been in perfect balance for the past 9,500 years. The natural cooling has been perfectly balanced, almost perfectly balanced, by human activity. And so for the past 9,500 years, we've had extreme climate stability at the optimal global mean temperature for sustaining global human high technology civilization. So the question I leave with you is, do you think this is an accident, or do you think somebody had this in mind billions of years ago when he created the universe? That's my 14 minutes worth. So you can ask me literally anything. We got one rule for the Skeptics Forum: no softball questions. We only want hardball questions. So whatever questions you got, questions you've been hearing from friends, we got a microphone there, and you can come to the microphone. Matter of fact, here's some instructions here. When you ask a question, go to the microphone, speak directly in the microphone, and please be concise. Try to be as concise as the people that are texting their questions in. That'll really help us, and we're going to alternate between text questions and questions that we take from the microphone. And by the way, if you're too shy to come to the microphone, you can text your question in. We'll treat you just like somebody from Germany. So, and that's the text number again that you can use to get your questions in.
Some of these text questions aren't so concise.
They're not so concise?
No, but here's a good one. We'll start with this one.
Okay.
My name is Sarah from a small town, Hibbing, Minnesota. I've been there, Sarah. My question is, why do we assume there was nothing before the Big Bang? Is it possible there was something physical rather than nothing? Thank you.
That's a good question. And, the universe is an effect, so it's got to have a cause. And one of the things we observe about absolutely nothing, it stays as absolutely nothing. And that's a principle we see ubiquitously in science, that the effects are never greater than the causes. So the idea that we could get something from pure nothing actually defies everything we observe in science. The effects are always lesser than the causes. But I would argue that there was something before the universe, that there was an agent beyond space and time, a personal being that decided to create this universe of matter, energy, space, and time. And we actually got hard evidence for that. One of the books we're giving away here is the 4th edition of The Creator and the Cosmos, and there I document the latest scientific evidence that there must be a causal agent beyond space and time who is a personal being that's responsible for creating our universe. And you say, why do you think it must be a personal being? Because everything about the universe, every component, every event, shows fine-tuning to make possible the existence of human beings by an agent who's intent on eliminating evil from the human species. So anyway, you can read about that in the Creator and the Cosmos, in particular the space-time theorems, which establish that if the universe is expanding, then there must be a beginning to space and time itself that coincides with the beginning of the universe. And I give a quote from one of the authors of that space-time theorem, Alexander Vilenkin, a Russian astrophysicist who's living here in the States now. And his whole point is, based on this theorem that he and his colleagues produce, there is no escape. We have to face the problem of a beginning of space and time and the implications of that space-time beginning. He never addressed what those implications are, but I think it's obvious. There must be a causal agent beyond space and time who created our universe of matter, energy, space, and time. Incidentally, a couple of weeks ago, I did put out a blog article. Every Monday, I post a blog at reasons.org. And that particular blog was the latest measurements we have on dark energy. Dark energy is a dominant component of the universe, and we now have measurements that tell us if there's too little dark energy, we're going to get blasted by gamma ray events that'll drive us to extinction. And if the dark energy is too powerful, we wind up being killed off by supernova. And that dark energy term has to be exquisitely fine-tuned to make possible our existence. Theoretically, we had determined that it had to be fine-tuned to better than 1 part in 10 to the 122nd power, but now we got actual physical evidence, not just theoretical evidence, observational evidence, that tells us it must be fine-tuned to that degree. And I've argued that that proves that this causal agent must be a personal being, because you're seeing fine-tuning to make possible our existence that's 10 trillion, 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 trillion times greater than any fine-tuning we human beings are capable of manifesting, which would imply that the causal agent is more intelligent than we are, better educated than we are, and better funded than we are. And that can only be true of a personal being.
Everybody's too chicken to go to the mic. Yeah, I've got some others, but go ahead.
There we are. Doug is asking it's kind of a compound question here. What is nothing? Or should I say, did nothing ever exist before the Big Bang? And what was there? What is the latest scientific news?
Okay, good question. And, there's a famous atheist theoretical physicist, Lawrence Krauss, that wrote a book, Universe from Nothing, where he claims that nothing created the universe. Not God, but nothing created the universe. Well, you'll see at reasons.org, if all you do is put into the search engine Krauss, it'll pop up a critique that I wrote of his book. It's a 2-part critique, in which I basically went through his book and said he introduces several different kinds of nothing, and every one of his kinds of nothing is actually something. And years ago, here in this church, I gave a sermon called Everything You Want to Know About Nothing, and basically made the point that when scientists talk about nothing creating the universe, in every single case, it's something. Matter of fact, they come up with 9 different definitions of nothing, none of which are really nothing. So, for example, one of the more popular ideas is that we see virtual particles come into existence out of nothing. Now, it really is true that we have these particles apparently coming into existence out of nothing. However, it's not nothing. It's space-time quantum fluctuations that pop these particles into existence. And quantum space-time fluctuations are not nothing. Just like you can take energy and make matter out of it, or matter and make energy out of it, because of E = mc squared, it's also possible to take space curvature and transform that into energy or to matter. And so quantum space-time fluctuations making virtual particles, that doesn't prove that's how the universe came to existence, for the simple reason. The laws of quantum mechanics come into play here. And what the laws of quantum mechanics tell us is, because of the Heisenberg uncertainty, you can get quantum space-time fluctuations producing real particles. But we call them virtual particles because that same uncertainty principle tells us they have to return to the quantum space-time fabric before we observers can actually grab one of those particles. The return time is less than 1/10 of a second. Now, the greater the mass that you make from quantum space-time fluctuations, the faster it must return to the quantum space-time foam. And if you're talking something as massive as the universe, it has to go back to the quantum space-time foam in less than 10 to the minus 122 seconds. And we got lots of measurements. Matter of fact, we got lots of people here that are proof that the universe is older than 10 to the minus 122 seconds. So the universe didn't come into existence that way. That's one example. Again, if you go to those, and by the way, there's a chapter in The Creator and the Cosmos where I also give a response to this idea that nothing produces something.
Good, thank you, Hugh. Here's a question a little more down to earth. is from Gary here in the audience. Is there any evidence or proof of Noah's Ark, or do we just accept it by faith?
Yeah, Noah's Ark. When you carefully read Genesis chapter 8, it tells us the ark came to rest on the mountains of Ararat. That's not Mount Ararat, it's the mountains of Ararat. And the Hebrew word for mountains is the word har. And that can refer to mountains, hills, foothills. It's a generic term. So, Hebrew has a much smaller vocabulary than English, and so nouns typically have a broader definition. So, and what I discovered talking to Armenian scholars is that the ancient country of Armenia was referred to as the mountains of Ararat. It encompasses 100,000 square miles. So I believe the ark came to rest on the foothills of Ararat, probably somewhere just north of Nineveh. And I don't expect we'll ever find the remains of Noah's Ark, because it tells us in the Bible that the ark was a minimum of 450 feet long, and it was made out of gopher wood. Well, to have a boat that size to be seaworthy for 13 months, or the 7 months before it came to rest, it would have to be made out of lumber that was stronger than oak. With oak, the limit's about 350 feet. So this would have been really valuable wood that be resting there. And what you notice in Genesis chapter 9 and 11 is that cities were built shortly after the flood. And one of them was Nineveh. So my guess is those humans living after the flood saw all that valuable lumber there in the ark, and they raided it to build the cities that you see recorded there in Genesis chapter 11. So if you want to find the remains of Noah's Ark, I would look in the ashes of Nineveh. But Nineveh was burnt to the ground several times, so it's not going to be easy to identify them as the ashes of the ark. But certainly, it's a waste of time going to Mount Ararat.
So we've finally got somebody at the microphone. Remember, any of you guys in the audience that want to ask a question, and we can actually hear your golden voice, go back there to the mic, or we can bring it to you. Go ahead, Gary.
Over the last few years, just working with somebody that is a Christian, but was trained for so many years in Young Earth, and they're kind of maybe starting to see a little bit, but I think their biggest hang-up would be on the Neanderthals and the hominid